In this complex number session 13, we are going to see how to find square root for a given complex number using formula. You know very well, square root of a plus ib, that is square root of a complex number, is also a complex number, that is x plus iy, and its value is plus or minus root of modulus of z plus a by 2 plus I into b by modulus of b into root of modulus of z minus a by 2. If you have any doubt with this formula, you can see derivation for square root of a complex number in the session 12. Right. So this is your x value, this is your y value. So applying this formula, we are going to get square root for a given complex number. Let us consider a problem. Moreover, you know, this b value should not become 0. Right. Now, let us try to find square root for the complex number minus 3 plus 4i. Let us consider this complex number as z, and let us try to find modulus value. Here a value is minus 3 and b value is 4. Here b is not equal to 0, so we can find square root to this problem. Right. Modulus of z is nothing but root of a square plus b square, that is equal to square root of minus 3 the whole square plus 4 square. If we simplify it, it will become 25, 16 plus 9. If you take square root for this, your answer will be equal to 5. This is your modulus of z value. And a value is minus 3. So we have to substitute in this formula. Let us rewrite this formula again. Square root of a plus ib is equal to plus or minus square root of modulus of z plus a by 2 plus I into b by absolute value of b into square root of modulus of z minus a by 2. Right. Simply substitute the values of modulus of z and a. That is, modulus of z is 5 and a value is minus 3. If we substitute it, plus minus 3 for modulus of z 5, for minus minus, for a minus 3, that is 5 plus 3 is 8 here, and 5 minus 3 is 2 here. So your answer will be, that is 2 by 2 1, 5 plus 3 8, 8 by 2 4. If we take square root, it will become 2, and we have plus or minus in the front. So now your answer will be, if plus goes inside, it will be plus 1 plus 2i, and if minus goes inside, minus 1 minus 2i. So your answer will be 1 plus 2i and minus 1 minus 2i. That's all. So no need of worrying with this problem. If you know this formula, it is very simple and you can find the answer very easily. Right. Now let us try to do one more sum, not with the square root, but with modulus, maximum value and minimum value type problem. Right. Let us try to prove this. That is, 7 is less than or equal to modulus of z plus 6 minus 8i, and that is also less than or equal to 30. How to prove this? We have two inequalities. We are going to use the two inequalities and we are going to prove this. The first inequality is, here the modulus of z is given as 3. Right. First inequality is this. That is, modulus of z1 plus z2 is less than or equal to modulus of z1 plus z2, and modulus of z1 minus z2 is greater than or equal to modulus of z1 minus z2. That is, when we use this property, if this single modulus is splitted into 2, the splitted value will become greater if it is under addition. If it is with subtraction, the splitted value will become lesser and it comes inside the absolute value. Keep this in mind, these two properties, and let's try to prove this. Let us take this complex number and its modulus value. We are going to split this. We are going to treat this as a complex number, and this is another one complex number. So if we split it, since it is with addition, so the splitted side will be greater. Right. Now, you know the value of modulus of z. It is given. So substitute it here. Modulus, you know very well, that is square root of 6 square plus minus 8 the whole square. 6 square is 36 plus minus 8 the whole square is 64. If we simplify it, we'll get the answer as square root of 100, that is 13. Square root of 100 is 10. 10 plus 3 is 13. So it is clear the modulus of this is less than 13, less than or equal to 13. So this complex number's modulus will be less than or equal to 13. It implies its maximum value will be 13, because it will take only the value lesser than this. It will take the value lesser than 13. So its upper bound or the maximum value will be only 13. So using the first inequality, we have proved this part. Let us use this second inequality. Right. So for this, we have to write the same complex number, that is modulus of z plus 6 minus 8i. It should not change. So I don't want to change it. So let us do a small thing. This can be written in this format. Minus into minus is plus 6. Minus into plus is minus 8i. So the same complex number is written in this way as a subtraction 1. So if we split this single modulus with subtraction into double modulus, as you know, the splitted will be a lesser one. So the splitted, which is under the absolute value, will be lesser one. Right. Now, for this absolute value, let us write the same absolute value. Modulus of z is 3. For this minus, this is square root of minus 6 the whole square plus 8 square. If we simplify it, it will become inside the square root as 100, that is 3 minus root 100, that is 3 minus 10. Our answer is minus 7. Since it comes inside absolute value, the value of this is plus 7. We have to change the sign. Now, if you see, this value is greater than or equal to this value. Am I correct? This value is greater than this value. So, this value, that is modulus of 6, modulus of z plus 6 minus 8i, that is this, will be greater than 7. It will take value like 7.1, 7.2, like that. It will be going on. So its minimum value is 7. So here we confirmed its maximum value is 13. Here we have confirmed its minimum value is 7. So this value lies between 7 and 13. If we combine these two, our answer will be 7 is its minimum value and 13 is its maximum value, that is 7 less than or equal to modulus of z plus 6 minus 8i less than or equal to 13. Practice these type of problems from examples as well as exercises that will train you more and more. Thank you.